Neurips 2024, Part 8, Smoothie, Label-Free Language Model Routing, Chris Ray and others. The problem that this paper is discussing is that if you have various large language models, you might be able to choose the right model for the right task. For example, a chatbot might be asked to write code, to answer questions, to summarize poems, to do various tasks. And one of the advantages in this day and age, with the open source community being so generous with models, you have access to APIs or Hugging Face to really choose different models for different tasks. So you could have potentially one chatbot that really can generate maybe code that can analyze protein data, genetic data, and it's not so clear right now. Actually, it's almost obviously the case that certain models are better for certain tasks, because in the pre-training phase and the fine-tuning phase, they were trained for specific tasks. Particularly things like code generation are not the same like text generation or mathematics. Famously, ChatGPT is not very good at mathematics, arithmetic actually, not even mathematics. So there's different skills for different types of models. And what this paper is trying to solve is how to choose between different LLMs. So what the paper does in particular is it first builds a framework of how to even estimate the quality of large language models. Then it builds a framework for how to route different large language models to different tasks. It also builds a framework for how to pick proper prompts, because that's another area of research, which is you could have several prompts trying to solve the same task, and the question here is, okay, can this router not just route me to the right models, but maybe also route me to the right prompts? Of course, I guess the next step would be a self-generating prompt, a prompt generator, right? So you set a task. For example, I want to do X, and then the chatbot actually can create its own prompt that it deems most valuable in order to solve the specific task. The authors are not going that far, but this is the obvious next step. What they're also doing is ablation, as usual, where they're trying to find different choices of different algorithmic choices. So, for example, one of the things they're doing here is a so-called nearest neighbor analysis. And they're looking at different levels of nearest neighbor. They have different choice of ensembles. So does it actually matter what models you have? Does the performance of Smoothie, which is the model that the authors are building, does it depend on the models available for choice? So there's all these types of, in my opinion, very interesting questions that can be answered in this work. Now, let's lean back for a second and just think about what is actually the problem here. The problem is, I think, on a path towards an agentic future, we need to understand how to use different models for specific tasks. So this is in that sense definitely very relevant. You could have code generation, you could have text summarization, you could have genetic information. You could have one chatbot that deals with all of these types of problems, which is, call it like the super agent, for example. So this would be, in my opinion, definitely, this is the North Star. This is where we want to go. The question then comes up, okay, how do we even measure the quality of an LLM, right? How do we measure whether ChatGPT or Llama or one of the other models is better for certain tasks? And there's already a sort of a cumulative problem here, which is we can maybe have a better performance with a specific prompt, but maybe if we use a different prompt, a certain other model could do better. So there's a bit of a moving target here, but in general, that's what the authors are trying to estimate here, which is, okay, what exactly does it mean a model is better than another model? And that benchmarking is a big problem per se. Liang talks about this a lot at Stanford. So we have we absolutely have to work on this, and what gets measured gets done. So once we have better benchmarks, we will also measure against them, and we have to be very careful to have the right benchmarks. So I think that's one of the milestones that this paper is setting, is also let's think about the benchmark. What does it mean to have a better model? And then what does it mean to route specific tasks to specific models, right? So in other words, if I have a coding task, can my model now route, assuming it knows which model is best for coding, is it going to route to that specific model? Now that to me seems a relatively easy task, but still we have to be conscious about this. Now, I think the most interesting part, in my opinion, of this whole work is actually the prompt analysis, because think about it this way: like, you could have an agent that you give the agent a task, and the agent figures out its own prompts. Like, this would be, in my opinion, the North Star of this particular subset of problems, right? Because as we know, chain of thought is kind of like the prompt engineering side of things, where you can get more out of a model without changing the weights, just by having a better, more intelligent chain of thought analysis. While you're trying to solve the problem, you're asking the right question. This is, even in philosophy, right? The Socratic model, where if I ask the right questions, I can get, something out of a pupil that they might even not know that they know. So this is very similar to, the Socratic model, or what is Aristotle? I think it was Socrates, that just through questions and answers iterates himself and the pupil towards the right answer, without ever actually asking the specific question that is at hand. And also the pupil doesn't even know that she knows what she's coming up with. So this is a chain of thought idea, and you could have a model like Smoothie is a beginning where we're trying to assess how well can we distinguish prompts when it comes to problem solving, right? Which prompt should be used for which problem? This is the fundamental question here, and I think that's really interesting, because you could imagine an agent where you literally ask, like, I wanna have a more efficient way to design this chip, and then the model prompts itself towards a solution here. So if we look at how we're using large language models today, we're kind of forced to be really good prompt engineers, right? The same with Google, or even more simpler tasks like doing a search on Kayak for a flight. For example, I just flew from San Francisco to Zurich, and I hacked the system by finding a flight from Zurich to Vienna, which gave me the first leg was San Francisco, Zurich. So I got basically the one-way, direct flight for a fraction of the price I would have paid if I had booked the direct flight. So those kinds of things are already, we're familiar with, better searches, better prompts, and what we want is a model that can hack that can figure that out itself. I think that's a pretty daunting engineering challenge, and I don't think we should take this lightly. But what the authors are doing here is, I think, opening the door for the questioning of this. And finally, also what they're discussing is the algorithmic choices. That's typical ablation study. For example, the way this model works is it actually it works with unsupervised data. By the way, I'm sorry, I forgot to mention that. Of course, that's very important. So what we have here is unsupervised data. So we're not labeling, we're not saying this model is good for this and this model is good for that. The whole idea of Smoothie is to figure that out in an unsupervised way. And the way this is done is through multivariate Gaussian, basically a statistical analysis where you have more similar answers are lumped together and considered more right than, let's say, answers which are sort of outliers. So it's a statistical method to, in an unsupervised way, combine the better answers and the worse answers, and thus kind of build quality models. And there is, for example, the question nearest neighbor analysis. How far should we go? How much of the nearest neighbor should we include? We have different ensembles. An interesting question, in my opinion, is, okay, does it matter what models we have? So if we have Llama, Llama 2, GPT, does the choice of models actually impact the performance of Smoothie? How does that work? So those are the kinds of questions. So to summarize again, Smoothie is a, in my opinion, very interesting approach by Chris Rhee et al. To tackle the problem of agentic systems from a model perspective, so to have more models at disposal and pick the right model for the right task. And that implies, of course, being able to assess the quality of the model, being able to route the model, and also being able to properly assess the prompts in order to solve the particular problem. Thank you.